Which of the following explains why the machine shown above has an efficiency of less than 100%? Now that's what we need to be thinking about, is that our efficiency here is less than 100%. Okay, the first answer, it says the effort force, that's of course when you pull down, is less than the resistance force. So this is basically my resistance force here, is my 25 kilograms. Now, that's not going to be true, is it? We're going to actually have our effort force is going to always have to be more. So A is probably not going to be a good answer for us. B, the load must be less than the force. This is sometimes true, but not always. So we're going to come back to that one. We haven't ruled it out, but we have to decide if it's right or not. The load and the force act in the same direction. Well, that's also not true. They act, opposite. It should be they act in the same direction. So that answer can't be correct either. The motion between the rope and the pulleys produces friction. Now, we all know from scooting across the floor, can you go as fast if you have on socks or if you have on basically roller skates or something that has a lot less friction? Anytime we have friction, it slows us down. It does the same thing with our ropes here. So we're going to actually be looking at our answer to be D. Whenever you pull on that rope, the rope's going to have friction with the pulley, so it's not going to be 100% efficient. So D would be the answer. The second question is dealing with the concept of convection. Now first we need to think about what is convection. Convection is basically where you have something, you're going to have a flowing pattern. How many of you have ever looked out as you're driving down the road in the summer and you see those waves coming off the pavement? Those are convection currents. There's a flowing pattern to them. When we heat a solid and turn it into a liquid, that's really going to be more about conduction because we're going to be thinking more about touching it. So that's probably not going to be a good answer for us here. Atoms in a solid possess a maximum kinetic energy. Well, the amount of kinetic energy the atoms have here is really not important in terms of being able to spread throughout. So that's also not going to be a good answer. Heat is rapidly lost from solids through radiation. Now, radiation is like we get heated from the sun. So since we're talking about radiation here, yes, you do lose heat from solids, but doesn't explain how heat can spread. So that's really also not a good idea for us. Now, particles of a solid are fixed in a rigid structure. That means they can't be moved. This is why heat can't spread through a solid. They're in a fix. There's no way that they can do what? There's no flowing. If you have no flowing, you can't have convection. So D is going to be our correct answer.